Welcome, everyone. We're just waiting a few minutes for everyone to filter in. So just give us a few minutes for a few more audience members to join. All right, I think that's a good place for us to begin. Welcome, everyone. This is the final series, this is the final part in the series of the Transatlantic conversation, begun by the Office of Science and Technology Austria at the Austrian Embassy in partnership with the UC Berkeley Institute for European Studies and the Centers Austria of North America. The event today is on sustainable water systems. How can we restore natural systems? How can we create sustainable water systems fit for human consumption? And how does Austria, a landlocked Alpine country, benefit from systems that are input in California and vice versa? The moderator for today's discussion is Professor Runzi Wang, Landscape Architecture at the University of Michigan School for Environment and Sustainability. So Runzi, I'm gonna pass the microphone over to you. And just so the audience knows, we're going to have about 30 to 40 minutes of discussion with the panelists, and then about 20 to 30 minutes of question and answer. Feel free to put your questions in the chat box, and we'll answer them towards the end of the hour. Thank you very much. Runzi, take it away.
Thanks, Ellie, for the introduction. My name is Runzi Wang. I am an assistant professor at School for Environment and Sustainability, University of Michigan. My research interest is urban hydrology and green infrastructure. Today, I'm very honored to moderate this important panel discussion on sustainable water future. So first, I'll briefly introduce some topics we are going to cover today. So this panel discussion will take an interdisciplinary approach to how human behavior influences the water cycle under climate change. Our discussion will cover a wide range of topics, including aquatic ecosystem, biodiversity, water quantity and quality, water consumption, and the associated technology and policy. We also have a special focus on climate change. Now, please allow me to introduce our two guests, our panelists, Dr. Sarah Yarnell and Dr. Paolo Dodorico. So first, Dr. Sarah Yarnell, she is an associate professional researcher at the Center for Watershed Sciences at UC Davis. Her studies focus on integrating the traditional fields of hydrology, ecology, and geomorphology in the river environment. She is currently conducting research that applies understanding of river ecosystem processes to manage systems throughout California, with a focus on the development and maintenance of river habitat. She also works closely with government resource agencies and private sectors to assess the impacts of environmental flow on aquatic biota and provide recommendations for developing flows that improve the functioning of river ecosystems. Let's warm welcome Dr. Sarah Yarnell. We are very honored to have you here. Now, let me introduce our second panelist, Dr. Paolo Dodorico. Paolo is a professor at Department of Environmental Science, Policy and Management at UC Berkeley. His research focuses on the role of hydrological processes in the functioning of terrestrial ecosystems. Through the analysis of the soil-water balance, he has highlighted important non-linearities in the coupling between soil moisture dynamics and plant water stress, biogeochemical cycling, land-atmosphere interaction, plant community composition, and soil susceptibility to wind erosion. He's currently investigating the globalization of water through water-water trade and international land investments, and its impact on water equity, societal resilience, environmental stewardship, and food security. Welcome, Dr. Paolo Dodorico. We are very honored to have you here. Okay, so we prepared some questions to initiate the discussions. So we have around 7 to 8 questions, and also we will have some follow-up questions if our panelists have interest. Let me start our first question. It's about aquatic ecosystem service. So we all know natural water systems support the delivery of crucial ecosystem services, such as fish production, water provisioning, and recreation. So we want to discuss how could climate change affect aquatic ecosystem services. Maybe we can start from Sarah.
Sure, great. Thank you so much, Runzi. It's a pleasure to be here and to have the discussion today. So I appreciate the invitation and look forward to our talk. Yeah, so climate warming predominantly is going to be, as most of us know, is going to be increasing warming air temperatures, right? So as air temperatures warm, that affects the hydrologic cycle. And so that hydrologic cycle then is really the changes that we will see in the hydrologic cycle is going to be really, that's where most of the effect is going to be on aquatic systems. So for example, and predominantly, it's always rough when you start off. And so I apologize for being a little, let's get into it and I'll be a little more smooth in my answers here. So climate warming is going to be increasing the air temperatures. That affects our hydrologic cycle. And the biggest shifts that we're going to be seeing with that is more intensity and energy in the atmosphere, which changes our precipitation regimes predominantly. So the impacts then on the ecosystem can both be from warming temperature, but in a lot of ways for freshwater ecosystems, it's that change in precipitation that's going to be impacting how that system then functions moving forward. So for example, in California, we're a very seasonal climate. We have cool, wet winters and long, dry summers. And the change that we will see from warming air temperatures is a shift to a little bit more of a pronounced seasonality and a shift in the type of precipitation that's going to be falling, particularly at higher elevations. So for example, instead of snow falling at higher elevations, if it's warmer, that precipitation will be falling as rain. So that shifts the way that the precipitation lands on the surface, and it's going to change the way that the water runs off, which in turn then affects the aquatic ecosystems that are reliant on that precipitation. And for rivers, for example, we have flow regimes that are reflective of that seasonal climate. And so shifting to more rain in the wintertime and less snow means that more water runs off our mountains and into our watersheds in the wintertime. Less is stored as snow in the mountains. And so there's going to be less runoff in the springtime as the snow melts. So you're really shifting the timing of when water comes down into our watersheds and into the reservoirs and coming down from the mountains into our valleys. And that's changing not only the water delivery to us as people and how we will receive the water, but it also changes how the water comes in for the aquatic ecosystem, the fish that live in the river. So we're shifting to earlier storms, more intense storms, essentially more flooding capability for flooding in the winter, and then potentially longer, drier, hotter summers because less water is going to be stored in the mountains to melt as snow melt. So you can imagine then for all the native fish species, for example, and other species that are living in the streams that have adapted and have their life cycles cued around these predictable flow regimes, when those flow regimes shift, it's going to add additional stress to the aquatic biota. So those are the types of impacts that we're going to be expecting from climate change. We're already starting to see that here in California, just in the last 5 years, more extremes, wetter winters, drier summers. There's a lot of talk about climate whiplash as these extremes get more extreme. And there's a lot of talk in California about essentially how do we as community members and people essentially learn to manage our floods to survive our droughts. So we're sort of moving into this situation where these extremes are going to become more extreme, which makes it more challenging. It's less predictable, really, both for people and for the aquatic environment. So maybe I'll pause there. If there's any follow-up questions, I'm happy to, or if Paolo has anything that he wants to add, but those are the biggest types of shifts I see.
Well, thank you again. Thank you also for inviting me. It's a pleasure for me to be here. I don't have much to add. I would just say that clearly, as Sarah was saying, that the impact of climate change on aquatic ecosystems is mediated by the water cycle. So it's important to see how the water cycle will change as an effect of warming. And at a global scale, there are indications that there are some areas that are becoming drier, other areas that are becoming wetter. The typical pattern is that the subtropics are expected to become drier, and the subtropics is where the dry regions of the world are already located, where most deserts are located. And so there are some concerns about the impact that this has on the water resource in these areas and on the rivers and the ways. The big question is to what extent the aquatic life will be able to adapt to this change and keep up with this change. The mid-latitudes and also equatorial regions can have, which are already relatively wet, are expected to have receive more water. And again, this is just talking about in terms of average terms. And then there is also how this water is delivered, what Sarah was referring to, when in the magnitude of the events, and so the intensification of extremes is also a big concern. And of course, when we look at the impact on aquatic life, we also need to remember that as the climate and water availability is changing, also humans need to change or are changing their reliance on these water resources. And so the two things will need to be combined to see how much water and when is left for the aquatic life in areas in particular that are undergoing an aridification trend or a decrease in water availability. So it's a very complex question because it involves both the impact, the way the natural environment is changing, how humans will respond to that. And this also opens big questions about climate justice, this big topic of climate justice, which refers also to the fact that not all regions of the world will be affected in the same way. And so the big question that countries that cause this, most of the carbon emissions that are driving the climate change are not directly affected by some of these effects of, or necessarily not the most impacted by the change in water availability. And then there is the way in which this intersects also with the needs of nature and to what extent the water resources necessary for aquatic life are going to be impacted.
Mm-hmm. Yeah, thanks, Sarah and Paolo. Yeah, I agree. Climate change is very complexly related to the water environment. I think in addition to the affecting the flood and drought, because I'm more water quality person, so also climate change can affect like water pH, nutrients, eutrophication, and that chemistry change also greatly affect the biodiversity in the aquatic ecosystem. So that's just from my perspective. Okay. So our second question is kind of very related to the first one about biodiversity, because we know most existing studies suggest overfishing is increasing now and fish stock are decreasing throughout most of the world. So in this question, we want to discuss what are the main challenges of fishery and aquatic biodiversity in the ongoing climate change context. So maybe Sarah, you want to start again?
Sure, no problem. Yeah, so you know, we see this very much in California. You know, one of the emblematic species, we have several runs of salmon in California. Salmon spend their life cycle, you know, coming in to spawn and rear, lay their eggs and grow in freshwater systems in the Central Valley, up in the mountains. You know, they're an anadromous species where they're migrating in, do their spawning and laying, and then the juveniles will migrate back out and they grow out in the ocean. So in some ways, they're a little bit of a, you know, they utilize so many of the aquatic environments, they kind of become a bit of a canary, right, in the coal mine in terms of being an indicator. And like most places around the world, our salmon populations have been absolutely devastated. In California, our native fish populations, over 80% of our native endemic fish species are endangered. A couple have already gone extinct, and there's a couple that are really on life support. They're literally being, you know, only surviving in hatcheries. And there's multiple reasons, multiple stressors on why the populations are declining. You know, overfishing is one in terms of, you know, it's a food supply, right? Not only like it is in many places around the world, but also the changing habitat conditions and the development, particularly of the freshwater systems in terms of the habitat available, you know, within the river systems and on the floodplains. We've, you know, we build on the floodplains, we put up levees on the floodplains. And so therefore the river no longer can access that habitat, which is really great spawning and rearing habitat. In California, because we're such a seasonal climate, you know, we don't get rain and precipitation for 6 months out of every year in the summertime. And so we've built dams in all of the mountains to hold back that snowmelt so that humans can use it in the summertime. We use it for our agriculture, we use it for our communities, but that blocks fish passage. So we've cut off a lot of the, you know, upstream areas that fish use for spawning. So we've reduced their habitat, both where they can access and places they can no longer access. There are changes in the ocean that are related to climate warming that are changing the cycling and dynamics of food availability. And then in addition, when you add the additional stressor of climate change, which is going to be warming, our flows and runoff are going to be coming earlier in the year. There's going to be less cold snowmelt. Salmon like cold water, there's going to be less cold water available to them. All of these really compound into, you know, just being like, you know, which one is the straw that broke the camel's back, right? So many issues that have reduced the populations. So when we think about what can we do moving forward to try to maintain these important populations, they're a food source, they provide incredible nutrients to the ecosystem, and they're representative of that larger biodiversity, right? Other species are also not doing as well. We tend to think about, so restoration, what can we do to make our river systems more resilient? And hopefully I know we'll come and be able to talk about some of those actions that we can do. And it's, so I won't get into that too much right now because I know we'll have questions about it, but it's really trying to think about what can we do today to try to limit that extinction. Like we're right there on the brink of, you know, plummeting biodiversity, a lot of our species not being able to survive, which in turn will affect us. That affects the water quality that people use. It affects the health of the ecosystem. And so, you know, we're right at that point where we need to be making some very big decisions about how to improve things and how to increase the resiliency in our system so that we can have fish moving forward, right? And we have these food stocks available.
I don't have much more to add because I think you covered everything, Sarah. So I think the only thing I wanted to stress, and I know we will talk about this more later, is that one of the main problems, first of all, that the aquatic ecosystems are losing biodiversity at a faster rate than other terrestrial ecosystems. And one of the main factors is human actions due to the withdrawals of water for mostly for irrigation, which is the big player in water consumption, human water consumption. So we have many rivers in the world that are left dry, they don't reach the ocean anymore. The emblematic case in North America is the case of the Colorado, that is dry at its mouth on the Sea of Cortez. The Rio Grande is not much better, so it's so this and many rivers around the world are strongly depleted. There are some as a result of that, some of these lakes in a basin of internal drainage, like the Aral Sea, the Lake Urmia, Lake Chad, are strongly depleted because of agricultural withdrawals, with impacts also on aquatic life in these systems. So humans have been pushing a little bit too much the boundaries and trying to have appropriated too much of these water resources, and as a result, often in disregard of the impact on aquatic ecosystems.
Mm-hmm.
Yeah, great. Thanks for your answer, both. For our next question, we will shift our focus from the water-related ecosystem to water consumption. Because the global demand for water will increase as the water population does, not only in terms of drinking water, but also for other consumptions-related expenses. For example, irrigation for agriculture and cooling for thermal power plants for energy are major water uses. So in this question, we'll discuss how do you view these crucial water supply challenges, as well as its relation to food security. I think, Paolo, you may have much expertise on this question. So do you mind going first?
Okay, yeah, I already anticipated some of this, I didn't realize it. So I think, yeah, we need to look first of all at what is the main form of human, how humans use water, and what is what are, as I said, the big players. And the big player is agriculture, because withdrawals of water for irrigation account for 70 to 90%. So would be, it depends on how they are calculated. Basically, if we look at withdrawals or consumption, evapotranspiration. And so it's a big amount of water, and with respect to this, drinking water is just a small factor. Municipal uses are smaller, and also industrial uses. But of course, they are very important locally, because when you have a big concentration of cities in arid places, and here in California, it would be the city of Los Angeles, for example, it's a city with millions of people, and you really have a big demand, localized demand for municipal uses. So this, of course, agriculture needs water, because to sustain the production of crops, we need to use water. And much of the irrigation happen, and many times about 20% of the agricultural land is irrigated, the remaining 80% is rain-fed. And so it's the irrigated land contributes to about 40% of food production. And we can say that about half or 40% of the irrigation around the world is done unsustainably, which means that it occurs either depleting groundwater stocks or eroding environmental flows. And so again, what I was alluding before, the fact that humans have been pushing too much, they are encroaching too much into the space that should be have been left to nature, and some of this agriculture cannot be sustained in the longer term. So this opens the problem that there is an increasing demand for water resources, and mainly because of the food system. And this increasing demand is due to two factors, mainly increasing population and increasing also in per capita consumption, because with the shift to food types and diets that require more water for their production, typical example is the consumption of meat that is increasing, especially in the emerging economies around the world. We see that there is an increasing demand for water resources, and to meet this demand, we often tend to look at how we can expand. Well, there are two possibilities. We either expand the agriculture, but the cultivated land, but this would be at the expenses of natural ecosystems. So usually it's not very supported by environmental scientists. Or we can expand irrigation in currently rain-fed areas to increase yields. And so while And the idea often has been that there is a big gap between the potential and actual yields. So it's possible to increase the production, but this requires water. So when we try to see where this is possible to do sustainably, we see that it's possible to increase food production to feed around 2.8 billion people. But then if we want to remove unsustainable irrigation that is already happening, we are down to 1.8. So if we put everything together, we see that it's still insufficient to meet the increasing demand for and from population growth and changes in diets. So this is just to say that many times we concentrate on increasing production. Instead, the new trend is to think about ways in which we can use water better or reduce consumption, changing diets, reducing food waste. That is about 25 to 30% of the food production. And I think this is, I can add more, but I think this gives us an idea of the big challenges we are facing.
Mm-hmm. Yeah, I'm not sure that I have much more to add to that, but I agree that it's not so much about trying to increase production, but how can we be smarter and more efficient with the water that we do have? It's a finite resource, and so we have no choice but to try to figure out how to be more efficient, how to be able to better manage, and we can't just you're not going to be able to have sustainable, healthy crops and healthy food production if we don't also have sustainable ecosystems. I think sometimes it's easy to mentally disassociate the two, but they really are intricately interlaid. And so we do have to have water then that is supporting the health of that ecosystem where we grow our food. And so being efficient and trying to deal with that is a big challenge. It's very complex, as Paolo said, and I think he summarized it really nicely.
Pardon me, I need to change the room. Sorry.
Okay.
Yeah, I very much agree that we should view the climate change effects on water consumption and ecosystem in a social ecological system, because those components are quite correlated. Our next question, I think, is related to the above all questions. We are going to talk about some climate change mitigation and adaptation strategies. Let me see. So our question is, what do you see as the roles of water system in climate change mitigation? In other words, how can we protect natural landscapes and human life from major climate-related events? You may want to talk about the potential climate mitigation strategies at local, regional, and global spatial scales.
Paolo, you want to start? Yeah.
Either ways, yeah. Well, I think the way I can contribute to this question is mostly by looking at the way water is, so some of the solutions or mitigations of climate change that have been proposed in the last few years really strongly rely on water. So like 10 years ago, there was a lot of excitement about biofuels, and with the idea that we can use photosynthesis to produce our fuels instead of taking and emitting carbon from below ground. And of course, that was an interesting proposition, but we know that first of all, it collided with the needs to produce food, and we already see that it's a short blanket, the agricultural system as a part of the food system. And also from the water point of view of water consumption, it requires a lot of water. So we have done some back of the envelope calculations years ago. If we were to replace all fossil fuels for transport needs with the biofuels, there would not be enough water. Basically, if we replace oil and gas with ethanol and bioethanol and biodiesel, and also wood for some, if we include also some power plants, so we replace coal with wood or other of these replacements. As overall, the total demand, the total water required to produce these biofuels would be equal to the total evapotranspiration from terrestrial ecosystems, which reminds us of the fact that we are using water from the past, ancient water that is stored through photosynthesis that happened millions of years ago and has been stored below ground in fossil fuels. So that's not a possible proposition, this idea of mitigating climate change by using biofuels and sustaining our energy needs with photosynthesis from today. So this pushes us in the direction of thinking about other renewable energy that are not based on fuels. The other thing is that in recent years there has been interest in negative emissions. So in the same way as the power plants can capture the carbon emissions from their chimneys, so in a way that the carbon is sequestered and not emitted in the atmosphere and stored below ground. Now there are some ideas of creating systems that are not only neutral but are negative emissions. So by producing biomass, again bioenergy, burning that and combining that with the carbon capture and storage in a way that we can effectively store carbon using photosynthesis. And again, this requires water. And so I just want to stress that there is always a water limitation also to these propositions, both because we need to produce biomass. Again, this is bioenergy. And also we need some water also for this carbon capture and storage technologies.
Mm-hmm. Can I ask a quick follow-up question, Paolo? I think that's a really interesting fact that I hadn't heard about how much water you would have to use all the water for the evapotranspiration. So is that part of the argument for moving over to solar technology and wind technology for energy production? Is that it would be a more sustainable path forward, and because of a lot of what you said?
Yeah, even though people have not been paying much attention to water, there has been a lot of the debate. Most of the debate is, which is rightly so, about the fact that most of the crops used for biofuels are flex crops. They are also food crops. And so they conflict with the food production, and not only in terms of availability, but also how this has driven the prices of food up during some recent food crisis in the 2008 and 2011. So there has been concerns about that. I keep talking about the impacts on water, but since it's still a small fraction of the energy needs covered by biofuels, this has often been disregarded because we haven't reached that. Nobody has even been talking about replacing completely the energy with the biofuels. But yeah, of course, that's then one more thing is that there is still interest in the second or third generation biofuels, which are not food crops. But still, this still has to happen, and has not been the biofuels we use now. And when we go to the petrol station, are biofuels from the first generation.
Got it. Okay, I might just add that some of the work that I've been involved in here in California with regard to carbon mitigation is sort of more along that restoration side. So complementary to a lot of what Paolo, you've been talking about, but the idea that in terms of trying to restore ecosystems, things like meadow restoration, floodplain restoration. These are locations, these valley locations in our ecosystems are places of deposition and storage, right? So the floodplains are where sediment has deposited over years and years, and those are carbon stores, essentially. And so when we farm that, or water erodes that soil away, a lot of that carbon is released back into the atmosphere. So there's a big push to, in terms of building back green infrastructure, the idea that if we can restore these ecosystems, make them carbon sequestering again, so meadows become not so much degraded, but they're back to growing and bringing and storing that carbon down in the soil, that not only, it has multiple benefits in that it's storing carbon down in the soil and keeping it out of the air. It's providing habitat and trying to help support biodiversity for aquatic systems. And here in California, these floodplain and meadow systems are also places where water is stored, right? And contributes those shallow groundwater sources of water. So water soaks into the ground, and then it will slowly leak, drain back into the stream channels. And that's what provides some of this low flow base flow in our rivers and water supply in the summer. So some of these restoration projects, and this has been a big emphasis and actually funded by the state of California to do a lot of these types of restoration projects because of their multiple benefits that are all really in some ways related to both improving ecosystem resiliency, improving climate mitigation, and actually trying to maintain our water supplies and maintain the good water quality. So for us, you know, in California, a lot of our water is coming from the mountains. And so keeping that water clean and cool and high quality by making sure that the ecosystem intact only, you know, is only good. It benefits all of the communities that live downstream from those watersheds. So that's another big effort that we're seeing, another tactic, or, you know, in addition to climate mitigation that's occurring and going on.
Thanks for sharing your answers. That sounds awesome. For the next discussion point, we are going to talk about technology and infrastructure, and I believe they are all effective climate mitigation strategies. So how can we use technology and infrastructure to create more sustainable water systems? For example, what are some new technologies in agriculture and new ideas in green infrastructure that can help mitigate and adapt to climate change? Maybe we can start from Paolo.
Okay, one thing I tend to say always that we shouldn't think that technology is always the panacea, the solution of all problems. Many times it's the cause of many of the problems we are facing today. And so there is often been this technocratic approach in finding new technological solutions to get us out of problems, and we have been digging our grave deeper and deeper. But with this said, there have been there's been interest in agriculture, for example, in developing methods that allow us to use water more efficiently, and in a way that we can get more, the so-called more crop per drop, so more production for every drop of water. And this has led to, for example, to methods of cultivation that tend to reduce evaporative losses and to have more transpiration, less evaporation, so more in a way that we can produce more food with the same amount of water. This is good, but and so the typical examples are drip irrigation and other technologies. These are good methods, but as a result of that, we tend to have also that there is less return flow down to the environment, and so which means also that there has been more or less opportunities to leach the soils out of, and protect soils from salinization, and also the less opportunities for groundwater recharge. So overall, farmers can use at their small scale more water, but then leave very little down to recharge the groundwater. And so this phenomenon is called sometimes the irrigation paradox, because we increase efficiency, but by increasing efficiency, we don't increase the amount of water that is available for the environment. And the other technologies that try to reduce, again, the evaporation from the soil surface, or there is sometimes, and these are technologies that can be applied in the field. There is interest in other technologies that allow for the production, for higher production in so-called hydroponic systems. Instead of growing crops in soils, we can grow crops in water, and then the water coming out of the water can be, the system can be combined also with some aquaculture in a way that we can have a system is called aquaponic, and allows to use the water with the that has been used by fish and it's been fertilized by fish, and use it for to grow crops, and then perhaps use some of these crops to feed fish and have some more of a circular economy type of systems. Of course, these are things that are very interesting, but are very hard to upscale. Some technologies require investments, and so these investments cannot be upscaled to the globe. Then in terms of the other thing that we have been talking about, I just mentioned, and I think Sarah will talk more about it, is that instead of looking at the technology and the new infrastructure, we can look at how the environment can already provide some services. So what Sarah was talking about now is an interesting system for climate mitigation, to undo some of the land use change or produce some land use change that can sequester carbon, and that and there are many other examples that apply also to the water system. Let nature do its own work. And I think, Sarah, this is more your domain.
Yeah, and so just speaking to the green infrastructure idea or nature-based solutions, you know, these are different terms that you might hear. The idea is to really essentially try to have humans step back a little bit, give a little bit more room for the river, give a little bit more room for the ecosystem to do its natural functioning. So floodplains are a great example of this, where, you know, traditionally we have drained floodplains to farm them. We've built levees on the rivers to keep the rivers in place so that we can build houses. But when you're doing that, you're limiting the ability of the river and the ecosystem to be dynamic, to spread out when it floods and soak into the ground, which then recharges, you know, groundwater. It provides all that habitat for different aquatic species. So it really is a big boost to biodiversity. And so when we're limiting all that, we're taking away all of those ecosystem services. So the idea behind nature-based solutions or green infrastructure is to try to step back that a little bit. So re-access the floodplain. Maybe we do levee setbacks as a restoration project, right? Or maybe in some places, if you have there's great examples of this in California with the YOLO bypass, which is a flood bypass system that is levied, but it has weirs where at high flows, the water can spill out onto the bypass system. So in the wintertime, it's flooded. It provides flood control. That water spreads out over the floodplain. It actually provides bird habitat during the wintertime for the migratory birds that are moving through. That water can slow down and soak into the ground. So it's recharging the groundwater where in places. And then as the flows pass through in the summertime, it's farmland. These are rice fields typically in California. And so it's a floodplain depositional environment. So again, this carbon is getting stored and sort of put back into the ground when it's happening. And so accessing that floodplain and projects that are essentially multi-benefit, trying to take advantage of those natural processes that actually, this is the way rivers work, right? There's a floodplain because that's where the flood flows go. And all the benefits that are associated with it is a way to think and change. That is infrastructure in a way, right? And so we call it green infrastructure because it's more nature-based. And those are the types of solutions that I think are really where we should be moving. They're going to have multiple benefits, and they're going to be more resilient because that's how the natural system really works, versus hard infrastructure with dams and levees that require constant maintenance. They require constant money. They can fail catastrophically and tragically. And so it's a little bit of a static way of thinking. And so I think we as communities can be a little bit more, you know, look towards these solutions that are a little more resilient and a little bit more flexible in terms of moving forward.
Thanks, Sarah and Paolo. I want to echo Paolo's emphasis on land use, because I think land use, broadly speaking, it belongs to green infrastructure, right? It's a natural-based solutions. So I am a landscape architect and urban designer, and from our perspective, some more sustainable land use planning, like placing riparian zone urban forest, and like maintaining more integral forest rather than sprawl it away, is kind of beneficial to water quality and flooding mitigation too.
And people. And our own societal, you know, just to have those green spaces with helping to clean the air just for our own social well-being, there's a lot of benefits.
There are. Yeah, that's true. We have many co-benefits about this land use, like having more people being equitably access to green space. That's kind of justice issue, and also providing the microclimate and so this kind of ecological benefits as well. So that's also something I think that should be studied in a systematical approach. And also
No, I want to say in this context that the riparian corridors and also coastal areas are very important because of the fact that they are wet. And so they are the carbon is not decomposed, or decomposes very slowly, and so these are good carbon sinks. All, for example, marshes, mangrove forests are all systems that are some of the most productive on Earth, and not productive in terms of net productivity, in terms of net carbon sequestration. And so this is by itself can be also interpreted as a green infrastructure. Let nature do its work.
Yeah, I agree. The green infrastructure has so many ecosystem benefits and social ecological benefits as well. Let me have a look at time. I think we have 50 minutes left, and we have one formal questions, and then we'll leave time for audience to have some question for us. So our last question is about policy and governance. It's another type of adaptation strategies. So to build sustainable and resilient water supply and management systems, what are some policy and governance interventions you want to emphasize? So Sarah, do you want to start?
Yeah. So policy and governance is a it's complicated, right? Because now people are getting in. We have to. How do we talk to each other, and how do we communicate and try to work together to manage these complex systems and these big challenges? In California specifically, I could speak a little bit to that. There has been a big push in the last 10 years with a couple interesting steps forward that I can mention and bring up, and I'm happy to discuss, and Paolo, I'm sure will weigh in as well. So the idea that there's actually been a big investment by the state of California in infrastructure. So we've had several big proposition bills. So these are taxpayer funded dollars to go specifically towards water and water supply, where things like green infrastructure are actually called out, right? So yes, there is a tendency a lot of times to put money into upgrading existing hard infrastructure. So, think of like canal systems that are in place that do deliver water and essentially aren't really going to be going anywhere, but might need to be maintained, but also in putting money into restoration, green infrastructure programs, and how can we build that? So the state of California has, and the legislature has actually moved forward with really providing funding for that. So that's been a big push forward. I would say one of the other big advancements for California is that during the drought in 2012 to 2015, the legislature passed the Sustainable Groundwater Management Act, which for California was incredibly crucial because we were one of the last states in the entire Western US that really considered surface water and groundwater separately. Surface water is heavily regulated. It has been for hundreds of years. Groundwater was essentially unregulated. And of course, they're fully interconnected. And in California, during our dry summer season, we rely on groundwater for our irrigation and our water supply. And so being able to formally, really recognize that and put regulations on that so that we can now collectively try to do a better job of actually holistically managing the water supply. And so what this requires is multiple government agencies to actually communicate and talk to each other and work together. And at least from my experience, having worked with a lot of the different state agencies in particular, that really is one of the biggest challenges. Is there's a lot of bureaucracy that you have to work around. And so any actions that can try to at least get folks between different silos talking to each other, moving forward, trying to collectively make planning agreements on how they want to manage things is really one of the biggest challenges and one of the biggest things that we can do to be beneficial. So it's getting, groups to talk together. I know over in Western Europe, for example, the European Water Directive framework has been, although I know it has issues as well, it's also been a big motivation for different countries to work together, right? So having these structures in place where there's some sort of guidance to encourage different communities to talk together, to work together to manage these systems, I think that's a big challenging, but it has to be done. There really is no other choice. If we really want to try to be sustainable in how we do this, folks have to be able to talk to each other and try to work across their silos.
But I would add a couple of things. One, as Sarah was saying, policy can really enable some changes. For example, the case of groundwater in California is important to enable also the establishment of new ways of also developing the green infrastructure we were talking about before. So one of the alternatives to the construction of dams is storing water below ground, which doesn't require, doesn't have some of the negative impacts of large surface reservoirs, including also the fact that there are almost no evaporative losses. Of course, there are other challenges, and so we need to have some sort of governance framework to regulate and to take advantage of this the opportunity to store water below ground. it's been estimated in the case of California that the below ground storage capacity is orders of magnitude greater than the existing surface reservoirs. So this can be really a promising approach in a place where it rains in the winter, but we need water in the summer for cultivation and other uses. So, and this could be a very effective way sometimes to develop policies that can enable some of the transformations we have been talking before in the previous questions. In the context, again, my focus has always been on agriculture, and I think another important factor is the fact that the food system is globalized. So we estimated that 25% of the food we eat as human beings in the world is on average accessed through international trade. In a similar way, we rely on, because of that, we rely on to feed the world on water resources that exist in other parts of the world. And so the United States is the net food exporter. So overall, the water resources in the US are virtually exported to the rest of the world. But at the same time, it imports some goods. So one of my students is studying the big import of some fruit products, particularly berries like strawberries from Mexico. There is a big demand for, and most of the Mexican exports of berries are to the United States. And so we see that as a result of this increasing demand because of healthy diets in the United States, for example, we are causing groundwater depletion and overuse of water resources in other parts of the world. This is just one of the many examples. And so China relies on feed from Brazil and South America, and to support the livestock production. So many parts of the world are strongly interconnected. There isn't a framework now to regulate these things. And we know that trade sometimes tends to be an easy mechanism through which we have environmental externalities in the context of manufacturing. We tended to produce things in the places where the environmental regulations were weaker and causing pollutions in other parts of the world. In a similar way now, we are causing unsustainable water use because of a lack of a framework and governance at the international level of the water resources that allow. And so I think the big next step and challenge would be to reach find a way to protect with policies and good governance water resources internationally.
Thanks, Paolo and Sarah. So we have 6 minutes before 11. So I think we can conclude this panel discussion and leave this time for the audience questions. I just saw that we have one question in the chat. So other audience, if you have questions, just feel free to type your question in the chat. So this question, maybe I can read it out. So could you talk about non-conventional water augmentation solutions, such as water reuse and aquifer recharge? What do you think are the barriers for implementing these non-conventional solutions across broader scales?
I could speak to the aquifer recharge question, because this is a really big, interesting topic in California because of our large Central Valley. There's a lot of interest and a lot of research and study that's gone into how best to recharge that main underlying aquifer, which provides up to like 60% of our water supply, right? In some years, particularly in drought years. And a couple challenges that have come up is in terms of where would you put the floodwaters? So where are the best places to flood land so that it really quickly gets down into the aquifer? So there's quite a bit of research on that. Some areas are better than others. There's some really interesting work that's been done on flooding different types of crop fields. Are certain crop fields better at infiltrating water than other places? And a lot of it has to do with understanding the soil layers underneath. What is the stratigraphy down below? For example, if you have, gravel underneath, that's going to allow, underneath the soil, that's going to allow water to percolate more faster. There's also other methods of using like dry injection wells where you, instead of pumping water out of the well, you're actually pushing water back into the well. Of course, there's challenges and barriers there, but it's a really interesting and very active field of research to try to figure out the best and most efficient ways to do that. But what's interesting about that too is what is not necessarily a barrier is trying to find places. So for example, you might say, oh, I don't know if a farmer would be interested in having his field flooded, but if he's in a good access and the state is actually helping to provide funding for that flooding of the field in order to do recharge, there's mechanisms in place to help support that. So I think there's a lot of really interesting research on that to really figure out how to do that, what we call managed aquifer recharge in really efficient ways. Exactly as Paolo was asserting too, it's a way to put water back into the ground and store water in the ground, which is an inefficient way to do it. In terms of water reuse, maybe Paolo might speak to that aspect of it.
Briefly, there is a lot of interest in this. I think the main challenge is that water reuse requires treatment. And also, so there is interest in finding other water that can be used, and one of that could be the reuse of water from sewage systems. The water could be used as ocean water or brackish water through desalination. There are all different types of treatments. And also the use of water from extraction, the so-called production water that is used for oil extraction for mining. So all these waters need to be treated, and the problem is always that the cost is high, but the costs are going down. And from what I hear from my colleagues and also from the literature, they are going down. And we did an analysis of for example, for sure this water can be used for industrial or municipal uses, because that water usually has higher value, and so people pay more for that water. In agriculture, it depends on how much the value that water generates, irrigation generates in agriculture, which usually is relatively low. It ranges between just as a very broad range, a few cents to $1. So if in the uses where water generates higher value, it could be like fruit production, and if the treatment goes in terms of cost goes down, there could be a really economically also a feasible use. And of course, we will need to do that with renewable energies, because we don't want to treat water and cause more carbon emissions. So I think to upscale this will take some time, but I think that could be a way to go.
Yeah, I also I'm wondering, what do this audience mean by broader skills? I think if you mean like regional or continental scale, there's a question of the priority, because regarding water, even in like one city, they can be like focused more on water quantity instead of quality, since you are talking about like groundwater recharge, water use. So these are kind of very different water related ideas. So based on my practical experience, I think the jurisdictions highly prioritize something that is really urgent. So if you mean the broader scale is like many cities or a state, I think we should be really careful about the local needs. So do they really need to augment the water recharge and reuse, things like that? Mm-hmm. So, okay, it's 11 o'clock. So I want to ask Ellie, do you have some conclusion remarks, or do you want to end this discussion?
I just wanted to say thank you all very much for joining us. That concludes the 5th part in the Transatlantic Sustainability series. I want to thank Runzi, Paolo, and Sarah. Thank you very much for joining us, and all of our audience members. You'll be able to find the recording of this video up on the UC Berkeley Institute for European Studies website, and also on YouTube. Thank you all very much.
Thank you.